Okay, so our objective today is to understand and use the formula for the area of a trapezoid. So this comes out of lesson 11.3. Okay. And I think I'm going to give you the theorem first, and then we'll go back and we'll draw some pictures so that you can understand where it all comes from. So we've got theorem 11.5. Bless you, bless you. So remember, part of your charge this chapter and next chapter is to work on memorizing your theorems, including the ones from chapter 10, especially the fourth one from chapter 10. The area of a trapezoid equals half the product of the height and the sum of the bases. In other words, A equals 1/2 h times the quantity B1 plus B2. So I kind of want to investigate this a little bit so that you can see where this formula comes from. We have a trapezoid. We have base, oops, that's not supposed to go there. Base 1, base 2. We have a height. Okay? Now, bless you. If I drew a diagonal, that diagonal plays a role. That role is that it splits my my trapezoid into two triangles. Okay? This, if I extended the side of B1, oops, and I drew the height over here, it's going to be exactly the same height, right? For both the triangle with base 2 and the triangle with base 1. So actually, we could say that the area of the trapezoid, using our area addition postulate, is going to equal to a triangle with base 1 plus the area of the triangle with base 2. So the area of the trapezoid is equal to 1/2 base 1 times height plus the area of the triangle with base 2 would be 1/2 base 2 times the height. Okay. So all I'm doing is figuring out the area of the triangle on top and the area of the triangle on the bottom. What do you know? Notice that both of those formulas have in common. They both have a half and they both have an h in common. So if I factor out 1/2 h from this first product, I'm left with B1. If I factor out 1/2 h from the second product, I'm left with B2. And there's your formula. It simply just comes from the fact that you have two triangles that make it up. Another way to think about it is this. What am I doing mathematically when I'm doing this part? No? What am I finding? An average of, that's right. the average of the bases ends up describing the median of the trapezoid. Now we'll get more into this in subsequent lessons. But that's basically what the formula comes down to, is figuring out the average of the bases, which represents the median of the trapezoid, and multiplying it by the height. And that's it. Okay? All right, so I've got 2 examples. Let's see if we can get through those. Everybody, no, they're still writing. Good, good, good. Now, interestingly enough, you know how they weren't really straightforward with you on your problems you had to practice? It wasn't like, here's the length of a side, figure out the area of the square. It wasn't that simple, but here's your first example. Find the area of the trapezoid. With height 7 and bases 12 and 8. Okay. So what we're going to do is take those and stick them into this formula. A equals 1/2 h times the quantity b1 plus b2. Now that half is going to get multiplied by either the h or the sum of the bases. It's not going to get multiplied by both of them. We talked about that yesterday. So we get 1/2, the height is 7, and the sum of the bases is 12 plus 8. Now, according to order of operations, we're supposed to take care of anything in the grouping symbol first. So we get 1/2 times 7 times 20. Now I can take half of a number. Well, the only number I could take half of would be the 20, right? And then I get 7 times 10 is 70. So there's the area of the trapezoid. Okay. All right, let's do one more. Find the area of the trapezoid with legs 5 and bases 6 and 10. So to draw this picture, what kind of trapezoid are they talking about? An isosceles trapezoid. So remember the formula says 1/2 the height times the sum of the bases. Well, I got the bases, but I don't have the height. So what I'm going to have to do is figure out the height. Because this is an isosceles trap, this is 6, and these pieces would have to be 2 because everything is equal on the bottom. So I had to split 4 evenly on those 2 little pieces. So the height, I can use Pythagorean Theorem to solve. So height squared plus 2 squared equals 5 squared. Unfortunately, not a Pythagorean triple. We get height squared equals 21. Take the square root of both sides, and we get the height is square root of 21. Now we can take this and plug into the formula. So we get the area is 1/2 radical 21 times the sum of 6 plus 10. So we get half of radical 21 times 16. Half of 16 is 8, and we get 8 radical 21. And that's what you're going to be working on tonight.